6, the top of page 6 of our packet. We have been working on balancing equations and writing the equations. Now we're going to do a little investigating where we're looking at it to try to give a little bit more information. So we're going to classify each reaction. So one thing when you really are classifying, compare the reactants to the products. You have to look at a couple things. Look at the first side. What am I starting with? Then you're going to, sometimes that can tell you right there, looking at your reactants can tell you what kind of reaction it is. If that doesn't tell you, check out the products. Then you're looking at how did it change. That's the number one thing you have to ask yourself. What changed? Because if you can tell yourself what changed, or more importantly, how did it change, that is going to be how you classify it. So down here, these are our 5 types when we start saying what type of reaction. Synthesis, decomposition, single replacement, double replacement, combustion. We're going to give them some little nicknames, kind of like relationships. That's not what we're looking for. We're looking for the real names. So this is vocab. Do I need to know this? Yes, you need to know these names. We will not be giving them to you. So that quiz we talked about on Monday, these are the names we expect you to know by that time. Okay, so let's start at our first one. It's a synthesis. Sometimes I've seen these called a combination. If we're talking about our relationships, this is going to be known as the marriage. Because look at what we're going to have. 2 individuals making together one compound. So typically you could have a element plus an element making a compound. So look at what I have. 2 coming together to make a compound. Sometimes though you can get 2 compounds combining to make a new compound. But what happens is really important. So here's our picture of it. One thing combining with another thing to make one brand new thing. Okay, so always, how can I look at this and know? Look at the product. This is a bad font. So if I'm looking at the product on this one, always has only one product. Okay, so when we said sometimes you can look at the reaction and know, that's what you can tell. If you look at something and there's only one product, one compound, and this one product has to be a compound, then you know it's a synthesis reaction. So let's just look at some examples. Magnesium plus oxygen gives you magnesium oxide. We would go back and balance it, because we pretty much balance everything now. You guys are balancing fools. And this is a balance, but look at one product, you're making a compound. Okay, lithium plus oxygen. Oxygen is one of my 7 diatomics. Makes lithium oxide. Plus 1 minus 2. Lithium oxide. What did I make? One compound. We need to balance it. And then you're going to have 4 lithiums. So I'm not talking about the one, it's not talking about after we've balanced. The one just means there's nothing with a plus sign here. Sulfur dioxide reacts with water to form, sulfurous, remember comes from a sulfite, H2SO3. Now this is one of the times when we write our skeleton, look at it's already balanced. But we still, one product. What do all syntheses have in combination? One product. So it's a marriage. You're making one couple, okay, one product. Sometimes your product might not, sometimes your project, so if you look at here, might be more than just 2 elements. But again, it's only one compound. Okay, that's a synthesis. Well, let's look at what happens if you take a synthesis and you look in the reverse. We decompose it. Okay, look at decomposition. If a body's decomposing, what is it doing? Yep, it's breaking apart. So if we're talking a reaction, as a synthesis is a marriage, this would be the divorce or the breakup. So look at what we have. So what is always true with decomposition? So on this, you have always true. You always start with one compound. So this means this one compound is going to be on your reactant side. So look at here. One compound now on the reactant. This is the only reaction you're going to see that has only one reactant and it's just going to be this reactant has to break apart. Synthesis is the only one that you guys will be seeing at this point that only has one product. You know you're making one thing. Keep those in mind, and that's how you can look and identify. You're going to have to get some key things that kind of make sense in your head. To do a decomposition, some kind of energy. So sometimes you'll see heated, and something is heated. Another way we can do this is electrolysis, which is electricity. So if you see these additional words added, it's just saying, okay, I had to apply some heat because things don't normally just start decomposing, even if it looks like it's doing it on its own. It's getting the heat from the environment. It's still taking in heat somewhere to decompose. It's going to take some heat energy to break the bonds. But again, one compound breaking apart into two different parts. So if we look at some of our examples, magnesium oxide, notice this plus heat. This isn't a reactant. It's just that extra information. Sometimes they might put the heat over the arrow. It's just saying, okay, I'm giving you some new kind of information. A lot of times this isn't involved. You may not see that. It means the same thing. And so what happens, it breaks into magnesium and oxygen. And then we go back and we balance it. So we'd have to put the 2 there to make sure that everything is balanced. Okay, notice again, diatomics. Don't forget the diatomics. So look what I have here, hydrogen chloride gas. I'm not calling it an acid because it's not dissolved in water. Add heat, it breaks into its elements, hydrogen and chlorine, both diatomics. Take water, we can break apart water. And you take water and break it apart and it gets broken into hydrogen gas and oxygen gas. Iron chloride, break it apart into iron and it's chlorine. And we need to finish balancing in this because this is 6 chlorines. So we would have to put a 2 here, and that's where our 2 irons and our 2 irons. So these were only half balanced here. I don't think any of them was balanced on yours. But decomposition, breaking it apart. Synthesis, putting it together. Okay, the next kind of reaction, single replacement. Okay, this is called the Homewrecker. Okay, look at what you have. Key thing. It's always one element, a single element, hence the word single element, and a compound. And what happens? This compound comes in and kicks it out. So A was by itself over here, compound B was with X. Now look at B is out all by itself, compound A is now with X. Compound A came in, kicked out B, replaced it. Now it has the compound. B is kicked to the curb, is all by itself. You always are going to get an element and a compound, and you're going to make a new element and a new compound. So that's a key thing right here. An element and a compound. You don't get 2 compounds. So we're going to look at as a comparison what we talk about next. When we start looking at predicting the products, we'll realize these don't always happen. But right now we're not going to worry about it because everything we're going to give you at this point, if we wrote it down, you're assuming it's happening. But we will come back and spend some more time on single replacements. What does happen is a metal is going to kick out another metal because they're both like charges. So a positive has to kick out another positive. So a halogen would kick out another halogen. So you can only have like things kicking out. So look at this picture. If we wanted to color these could be yellows. And look at what I have. I guess we don't even need to color. Look at the differences. Then over here, these are off by themselves, and now this would be in the compound as you're going through it. So it's like, okay, how do I recognize it? Look at what happens. This is where you have to compare. On this side, chlorine is by itself, bromine is with a partner. But look at what happened over here. Chlorine kicked out bromine, so now the chlorine is with the potassium and bromine is by itself. Remember the 2's because any diatomic, all halogens are diatomic, so when they're by themselves, that's when they have to get the 2. Okay, this activity series is kind of like this is when it's going to happen. Fluorine can kick out chlorine, can kick out bromine, can kick out iodine. But what I know, fluorine kicks out chlorine, you get potassium fluoride then, and chlorine happens. Halogen, the other type of reaction, same thing, we're still looking at single replacement. A metal can kick out another metal. So magnesium is a metal, iron's a metal. So magnesium's by itself, iron is with nitrate. But look at what happens over on this side. Magnesium is now with nitrate, iron is by itself. Okay, zinc is by itself, copper is in a compound, but on the other side, copper is by itself and zinc is in a compound. Okay, now you might notice on your packet, this is written in a different order. It has zinc sulfate written over here and copper. These order that these are written, it does not matter. It's the same thing, just like in math, adding them, it doesn't matter. I could put this in a different order. So the single element is not always going to be written first. This could have copper sulfate plus zinc. So you need to be able to recognize that it's a single element and a compound. The single element doesn't have to go first. Copper with silver sulfate. So what's going to happen? Copper is going to be with silver sulfate. Excuse me, not silver sulfate. Copper is going to just be with sulfate, excuse me, and silver is by itself. But look at how you know. Single element in a compound. On the other side is another single element and a compound. So if that's a single replacement, okay, the next one we have is a double replacement. Now, if we're talking relationships, there was a TV show on a few years ago. Wife swap. Partner swap. If you're dancing, you go out on the dancing, you decide to switch partners. So look at what's happening. A was with X over here, B was with Y. Now, when we get, it's kind of like a double rainbow, I believe Mrs. Fisher talks about. And so that you're going to have A is now going to be with B, excuse me, A is going to be with Y, B is going to be with X. When we start writing these, when we start looking at them, we're going to start talking about those states, and maybe if we don't even talk about as much this unit, they're definitely, like I told my class, I know, coming back a little bit in the next future weeks because the states tell us so much, and with double replacements it's really, really true. But this is the one for right now at this point. Let's not focus so much on the states. Let's worry about compound, compound, new compound, compound. It's just a double switch going on, double replacement. I'll never have two metals over here because that can't make a compound. So you still have to have metal, non-metal, metal, non-metal, or a positive negative with a positive negative. So we are going to be talking about the majority of ionic compounds. Sometimes an acid, which doesn't look always like an ionic, will be happening with this, and we have an acid-base reaction. So again, what's happening, you get two different partners going on. So in this one, silver was with nitrate, sodium was with chloride. So look at what happens. These are switching places. Or now I'm going to have silver is going to be with chloride and sodium is going to be with nitrate. But when we write our compounds, there will still be written the correct rules that you always write your sodium first or your metal first. So you still always write positive, negative when you write the compounds, and that's why it's going to be written in the correct way. So if you look at, this is again a skeleton equation that's already balanced. So look at here, potassium, that's my positive, my negative, my positive, my negative. Look at what happened. Potassium was with nitrate, but over here calcium is now with nitrate. Potassium, calcium was with chloride, but what's going to happen then? Potassium is going to go with chloride. Did I say calcium was with chloride? So what do you get? A double switch. And again, we're not worrying about the states at this point in time. We will come back and talk a lot more about it. What we want you to focus on now, compare the reactants to the products. What is happening? Okay, our last one is we're looking at this. Okay, we'll come back. We'll kind of talk about this. Why does something happen? Really, I'm going to wait and talk about this next week when we start talking about predicting products. So we're going to kind of wait of this. But this is to show why the states, you either need to make a solid, a liquid, or a gas. Solid, liquid, or gas. Somehow a molecule has to be made. We will definitely revisit this. Okay, the last reaction. I don't really have one to do with the relationship. This is a combustion. Okay, combustion. Fire. Something burning. What do we know about all combustion? Any fire. Fire produces heat. You always get heat out of these reactions. They're not always going to show you the heat or the energy. Just know that you always do produce heat or energy with combustions. Okay, now with these, there's a couple things to always be looking for. First, it has to be burning in oxygen. Any fire needs oxygen to burn. Okay, you are going to see hydrocarbons. Break this apart. Hydrogen, carbon compounds. Sometimes it might be a carbon, hydrogen, oxygen. And when typically you get written CX, sometimes it might have an O here. This is what you're looking for a hydrocarbon. Okay, so this is on the reactant side. When you look on the reactants and you see these both happening, that can tell you that it's a combustion reaction. Then you have to look over here. Another thing you're looking at, look at your products. Notice, always, this is always what you're getting out of it. You get carbon dioxide and water. And again, I could write down sometimes water and carbon dioxide. It doesn't matter which the order, but it does matter that you always get these out. You always get out carbon dioxide and water. It's the products. So look at what you have on your sheet. Okay, so look at on your sheet. What do I have? C2H6 plus oxygen produces CO2 and H2O. Always get. These are easier to identify. They're kind of a pain in the behind sometimes to balance. But look at, it's always this out. So what I want you to do is go ahead and balance these. Look at CH4 plus oxygen. What do I get out? Now I wrote water and carbon dioxide. I don't care the order that I wrote them. I care that carbon dioxide and water are there. Okay, look at the last one. This is an alcohol, but it's still a carbon, hydrogen, burning in oxygen, and what do I get out? CO2 and H2O. Again, I'm going to let you balance these to recognize, and that'll be a good place for us to start. We will see you in the morning. I need to change that. Okay, I won't always see you tomorrow morning. We'll see you tomorrow. What else can we say? Work on that. We'll have to think of something new to use as a sign-off. Anyway, see you tomorrow.